Good afternoon. I'm sorry that we are late, and I am painfully aware that I am the last act between you and happy hour. So I shall make this as painless as possible. Pay attention, there will be a test at the end, but the successful passing of the test will actually result in what I assume to be an adult beverage. So with that said, good afternoon. My name is Peter Groth. I am the Vice President and General Manager of Hewlett Packard Enterprise's service provider and OEM business worldwide. And what we're going to do here over the next 20 minutes, and it will be no more than that, I do promise that, is we're going to take a look at an actual OCP, core kind of topic, because we are actually going to be looking at OCP projects as in true open compute that we have brought through OCP along with the rest of the industry, and that's resulting in a series of products within the compute space, x86 based right now, that is essentially helping us in terms of how we can build portfolios at scale using a modular approach that thereby drives commonality, simplicity of operations, yet at the same time allows you to tailor the platforms specifically to your needs, your workload, and your use cases. So this is a consortium that is known as the DCMHS Consortium. It is a consortium that consists of ourselves, our great colleagues at Dell, as well as a couple of our great customers. We got Google in there, Microsoft's in there, Meta's in there, and we have obviously the CPU vendors, whether it's Intel, AMD, or Ampere in there as well. And the base premise of building DCMHS was essentially that while the tier ones recognize that they obviously have the opportunity to be selfish in the way that they design their things, they are also no more selfish than they recognize that many of the innovations actually comes from the community itself. And involving the community in building open standards and open standards-based designs actually benefits them as much as the rest of the industry. It allows them to go out and leverage the innovation that happens at every single vendor. And if they can bring together that into a standard that's seamlessly intercompatible from vendor to vendor when it comes to component level choices, that actually is a game changer, not just for them, but for the industry in general, because it allows innovation to come out faster and not necessarily just be driven by your traditional cadences, which are driven largely by the CPU vendors. So modularity was essentially born out of the idea that we wanted to have a reduced set of componentry that could therefore help us drive volume, but was infinitely recombinable across the portfolios of various companies to essentially bring forth a combinatorics set that allows for the building of the perfect fit. It's a little bit like going to the tailor, right? You can go and you can get, your next jacket. You can get it at whatever store it is that you normally buy clothes in. But you can also go down to a tailor and now you get something that fits you. The downside to going to the tailor is it's typically quite expensive. However, if all the components in your jacket was actually commercial, off the shelf, and it was commoditized, then being able to get that jacket would and should not be any more expensive than going and getting it off the coat rack somewhere. That is the fundamental idea of DCMHS. Now, this is not to say that there hasn't been tries at this before. I note that, Mike Gill, one of my great former colleagues, and who used to run R&D for us, along with Jeff, are sitting in front of me. We actually drove all the way back in 2006, 7, 8. We drove a program inside of Hewlett Packard Enterprise, back then Hewlett Packard, that was about modularity, and it was about realizing these sort of things. I think lovingly we called it Mr. Potato Head, because it allows us to basically take the toy and place arms and legs wherever we wanted to. The fundamental problem with it was twofold. One, it was a standard that was shared by exactly one vendor, that was us. And secondarily, it was not interoperable in terms of the fact that the software layers that is required to bring together all the discrete pieces of a server to actually make it into this bootable operating system running kind of thing, right? Whether it's firmware, whether it's drivers, whether it's complex logic, whether it's FPGAs, whatever, that technology back then was not resilient enough to actually make it truly modular, that it could self-assemble. That has taken the industry probably 10 to 15 years to get to. However, we are at that point today, helped out by things like UEFI, but also general advancements in not just connector layout and system integrity, but also how firmware and software in general have come to fruition. Back in the old days, firmware used to be something that was written on, these myopic kind of like real-time OS systems, and there was very few people who could seriously write code safely into that environment. We have since, with the help of OCP and the community, moved that ball forward to the point where, frankly, BIOSes and operating environments today, even at the logic device level, is actually nothing but Linux. And there are millions of people who can actually write code safely into a Linux environment. So this has now given us the foundation to finally build something that not only gives us greater control about the outcome, but also gives us the ability to be much, much more nimble while still driving hardware platforms that are fundamentally based in commodity economics driven by scale. And that is where DCMHS as a standard has basically come in. So what is that? Well, what it is that it's essentially, think of existing platforms today. You go out, you buy a platform, it has X number of features in it, and what you see is sort of kind of like what you get. Right? The server is made out of this big monolithic motherboard, and there's really nothing you can change on it. You can choose to not populate parts of it, but it doesn't actually disappear. It's not like you can take this motherboard and say, well, this was built for 2 sockets, but I only really need 1, so let me run it through a table saw, and then I should be left with 1/2 of it. Well, guess what? That doesn't work. Now, if the processor complex happened to be a module that was standardized in its interfaces to the rest of the system, now I can actually swap that thing out, and I can get exactly what I need. Likewise, if I wanted to have 24 drives on my drive backplane instead of 12, I don't have to go out and buy a different server. I just have to buy a different backplane. And so what effectively has happened is that we've gone from monolithic designs to modular designs, and the way it looks is essentially like this. There is a platform host module, which is where your Intels, your AMDs, your Amperes, your RISC-Vs, your whatever are basically living. There is a platform infrastructure connector capability, which essentially allows for things like PCIe. It allows us to route for drives. It allows us to route for things like backplanes, whether it's I/O with plug-in, whether it could be NVIDIA, or AMD, graphics modules, et cetera, et cetera. It gives us the flexibility to basically put those modules in, and then it gives us a standardized power domain. Standardized as in power supplies that are now the same power supplies across the entire industry. Why is that? Well, a company like HPE, we probably buy and sell, a few million power supplies a year. Maybe maybe 3, maybe 4, it depends on the year. So we can obviously drive a certain price point on those things, and our engineers do a phenomenal job along with our partners to drive that cost down. But at the end of the day, I only buy, call it 3 million power supplies. Now, Tim and his boys over at Dell, they probably buy about the same. right? Paul and his boys over at Lenovo, they probably drive the same as well. And then we got a bunch of other people who are buying power supplies. Now, all of those power supplies have thus far been unique. They're different. Well, what we're doing in the power domain is not only are we standardizing that so we can drive the cost down as an industry, but it now opens a whole different world in terms of how the infrastructure in data centers, and more importantly in colos, are now being driven to a much more efficient standard where every single server in the world, regardless of which vendor it comes from, can now get plugged in and have the same standardized environment, not just for management and power domain, but also for efficiency and wiring. This is a huge game changer just for the basic cabling of the data center. And as you start to then realize how the rest of the systems also, for whether it's for the processor modules, whether it's for the I/O environment, or whatever it is, for that matter, even the chassis, as those get standardized, you now, as a customer, do not have to compromise on anything in here. You can go and you can get your backplanes from one manufacturer, your motherboards from a different one, your chassis from a third one, and then you pick a system integrator that then binds all of that together with the last piece in the infrastructure, which is what we call the SCM, which is the secure platform module, or control module, we call it. This is where all the smarts live. This is where all your instrumentation lives. This is where your security lives. This is also where all the firmware comes from. Yeah, you heard me correctly. There is no more firmware inside of the system. It all lives on your secure control module, which means that gone are the days where you actually have to flash the environment. You actually don't even have to flash the management platform anymore, because that thing boots remotely from one centralized location, so that you in your environment effectively have a single lever operation for updating your entire fleet. Whether it is on the BMC, whether it's on the processors, whether it's on the NIC cards, whether it's on the plugins, on the drives, whatever. And that fundamentally is the game changer outside of the combinatorics. The ability to provide a very, very even and high quality experience across any of the combinatorics that you can choose to put together. So you can say, here is a picture of what MHS basically solves. You go from a monolithic environment where everything is pre-chosen for you, and where a series of product managers at company X basically stood out in the server making kitchen and decided what to pour into this specific server, soup that they made that day. In the future, just like you go out and you determine the number of drives or other characteristics of your configuration, you can now do that all the way down to the individual componentry. You can plug it together, and the firmware environment and the experience environment in and around it will actually click that together in an operational and 100% secure way. This is what the SCM does. It essentially goes in and replaces what is the human wetware that we currently apply to systems today. Today we spend an enormous amount of time inside of the data centers, regardless of the size of company, to do things like firmware recipes and other very, very arcane things, because the individual components, while governed by some level of a industry standard, PCIe, doesn't necessarily actually talk to each other once it gets to the logical level. So outside of the electrical domain, there really is no great standard. Yes, there are some things that are driven by the OS vendors, but it's sort of kind of like hit and miss, and any of you who's ever operated data centers at scale will recognize that this is one of those things that you spent the most time on. The second thing in the data center you spend most time on is actually mitigating security and security issues. So if you move the firmware conversation from where it is today to everything comes from a single environment in the middle where I have one centralized recipe that I myself control, and everything boots from that remote location, not only does it alleviate many of the management issues in and around, well, do I have stranded firmware, do I have stranded configurations, but secondarily, it mitigates an enormous amount of your security issues because you can now assume that if there is anything on the system, as in any piece of firmware anywhere, then that system has been tampered with and it's no longer safe. So instead of spending an enormous amount of time and effort trying to figure out how to harden attack vectors, the easiest thing to solve for the security issue is to remove the vector altogether. That means no more firmware that is not coming from a centralized location. And every single time you boot the system, you go in, you do a validation that what you have told the system to boot with is exactly what is there if there is a cached copy. I recognize that there are several CISOs who are looking at me now and going like, okay, that sounds really good, and I hope it doesn't come to fruition because then half of my workforce is no longer needed. I get it. But ultimately, this is the only way that we're going to be able to secure the domain of the data center, especially as it starts stretching all the way out to the edge of the network. So, does this actually come together? Yes, it does. There are a couple of products that are on the floor today. I recognize that I'm not the only one out there that has these systems. But if you actually want to go and see what these systems look like, how they behave, and how they come together, we have them out on the floor. I think Intel also has a wall of fame for DCMHS boards over there as well. There's quite a few of the other vendors out there that has this. And I think not only does that speak volume to the level of support that this standard has across the industry, but it speaks volumes to the fact that over the next generation of servers, whether it's the next iteration of AMD or the next iteration of Intel, this is going to be one of those things that you're going to have to start really planning for in the data center, because this is how large parts of the industry will be built. This is no different than if you go out and you try to build yourself a PC. Any of you guys build your own PCs? I mean, I do. I'm a nerd, so I do it, right? And one of the things I really love is like the ATX form factor, because I know I can go out and get any motherboard from any vendor out there, and I can get any chassis, and they will always fit together. This is how the server infrastructure in the data center is going to be going forward. Now, that being said, not everything is created equal. DCMHS at its inception was, and still is to this very day in its version 1.0, an electrical mechanical standard. For those of you who are keeping up with OCP work, and especially with the OCP wikis and the pre-reads and all those kind of things, will recognize that part of DCMHS was updated last week by the DCMHS consortium, which are now including not just an electrical mechanical standard for this, but an actual interoperability standard that guarantees that across vendors, that things will plug together and they will actually behave correctly. And that's a grand statement, especially when you consider that that now means that every single vendor out there is going to have to get real religion about security practices, implementation practices, and actually has to follow a programmatic standard for it. Not everyone's going to pass that bar. And of the people who are on the wall of fame right now in DCMHS, I expect that some of them are probably going to fall off, because that lift is not trivial. Anyone who's ever tried to tamper or tinker with your own firmware, being OpenBMC or open firmware, will know that this is a pretty hard lift. Even when there's a standard to govern it, that means that you actually have to have the engineering force to not just lay out motherboards, but to actually test and guarantee them, and not just in the moment of release, but actually over time. This is where a company like ourselves, or some of our other colleagues that are driving the industry with us in this direction, noticeably Dell, are stepping in and saying, we believe that even though that we are not the low-cost provider when it comes to procurement price of the hardware, the total cost of ownership, however, does matter. And in that space, we believe that we can very simplistically provide an experience at a superior cost over time that is not only tailored, but is trusted and is unified across all of the platforms and use cases that you may choose to run. So what does that mean? Well, tailored is essentially a set of questions around, does it fit my workload? Is it modifiable? Is it fitted? Is it actually personalized to what it is I'm trying to run? Or am I just simply doing a series of trade-offs to have as few platforms as possible, and then it's sort of kind of like it doesn't really fit any of my workloads, but it's close enough. Well, in an environment where you don't actually have to have different operational models or modalities depending on what the combination of pieces in the box are, why would you ever want to take that trade-off? It doesn't cost you anything. Today it costs you a lot because you're going to have 20 different models, and we all know that once you've got 20 different things in the data center, they're on 20 different carrying and feeding schedules, and they're basically like pets, not, you're keeping a zoo. If you can modify this without having any changes in the operational experience, now you're managing the whole thing as a herd, and now you look awful more like a service provider and a super or a hyperscaler than you look an individual shop. It's trusted because it's fundamentally reassured all the way back into the supply chain and down into the silicon. This is a statement that not every single BMC maker out there can make. And so when it comes to your security framework and when it comes to what it is that you actually implement, you're going to find that while all the commodities will continue to drive down a path of commoditization, your management and your security and your instrumentation is what in many cases will drive your choice of system integrator. Last but not least, it's a question about being unified in the experience. I want to be able to drive 200 different configurations in my environment, 200 distinct different shapes of servers, and have all of them work as a single piece of DNA where I load one single baseline for firmware, one single baseline for manageability, instrumentation, observability, etc., and have it work uniformly across all of it. This is what DCMHS promises to do. This is where the standard is and will be over the next few months. The electrical standard has been there since mid of this year. Products are now out for that. And all the software interoperability, manageability universe around it is going to be rolling in over the next 6 months. This truly opens an era for us in where we can finally realize the idea of having hardware being as agile as software is. We can introduce new modules at a modality of, say, 90 days cadence or what have you not, and at that point you can now cook that into your recipes without actually having to change any of your operations in the process. So this is what the next generation of compute is going to look like. And it's not just a statement from HPE. You guys can go out, you can take a look across the floor. There is not a whole lot of vendors that are not on this journey. It is interesting that there are some who have chosen not to be on the journey. And it's equally interesting that some of the people who are on the journey are not actually participating in the OCP work and therefore are going to be playing catch up every single time the foundation actually releases something out of the consortium. That being said, this is one of those kind of like data center design waves that is finally getting caught across the entire industry. Now, I only scratched the surface on some of these pieces here. So there are some specific sessions over the next day and a half that are going to dive into this. JBK, which is my chief field technologist for service providers, is going to be here tomorrow and be talking about what is the economics that this will actually drive. How does this actually come to fruition without costing $1 bazillion in the process? We're going to listen to Jean-Marie and to Jan Garrick from Scaleway that actually talks about how they have not just implemented a demo of, a proof of concept of this flashless firmware, but how a company like Scaleway is in very advanced stages of rolling this out to their estate, which is a few 100,000 hosts, and how this will actually work at scale. And with that, I want to say thank you. I want to invite you to come over and see the things in the booth and actually see the demos run in real time in front of you, so you can see that this is not vaporware. We're not discussing a roadmap. We are presenting an actual OCP project that has been working and that you as community members have been working on for the last couple of years, and how this is now rapidly becoming the industry standard. So thank you for your time, and enjoy happy hour.